Hi, today I would like to start the second video in my series of videos on building Yocto Linux for the ZedBoard. In the last series of videos we were able to compile a system, kind of a minimal system, and boot the board and see that Linux ran on those ARM processors. Today I want to take a slightly different approach. We're going to be heading toward the goal of being able to write a custom kernel module for the ZedBoard, and it's just a little inconvenient to have to pull that SD card out and pop the SD card back in and just to be able to test things out and be able to compile things. And so what I want to do is follow the next part of this, which is going to be to build the QEMU emulator. QEMU stands for Quick Emulator. It comes in two different flavors. You can either do an executable emulator or a system emulator. The difference being, if you had an executable for a system and you just want to run it and profile it, you can do the QEMU on that, compile a C program and run it on that. The other form that we're going to be using is the system emulator, where we're going to use the system emulator to be able to actually simulate an entire system, including a kernel, a file system, and all of the services, which is fantastic because then we can disconnect from the board and work locally on our faster PC. This is a document from Zynq, www.wikizynq.com. It's called QEMU Yocto Flow. I will post a link to this file on my website that's linked to the end of these videos. And they walk us through the process that we're going to follow for building an emulated image. And if you notice, it's going to do that same bitbake command, but it's going to generate a QEMU Zynq 7. And so instead of building for the ZedBoard, it's going to start building for the emulator. And so all of the hardware memory addresses of where things are going to refer to simulated hardware rather than the hardware that's embedded on the device. A word of note, this is not going to simulate anything in the programmable logic part of the design. So this is the kind of theme for this project is I'm building the 7-segment display driver. This is not going to emulate that hardware, it's just going to emulate the kernel and all of the other parts. So to get started, I'm going to open up a terminal window, and just as that command indicated, let's bring that command back here. We'll copy and paste this command, and we'll let this run on a decent machine. We're probably going to look at 10-15 minutes. I will catch up with you when this is finished. Okay, well that didn't actually take all that long at all. It only took about 5 minutes. Because we've already built a system, it looks like it reused many of the programs, and it certainly used the cache of things that were previously downloaded. So anyway, it went pretty quick. The next command we're going to try to do here is the run QEMU command, and this is going to launch a system emulator for the one that we just created. And so what we see is the Linux kernel booting. Yeah, there's a little recursion going on here. Yes, I am using a Windows machine as my host, with a virtual machine running a Linux server, Linux kernel now running a QEMU emulator for an ARM processor, running yet another Linux kernel. I wonder how far we could go. Anyway, if I log on as root, we are ready to go. This is a working emulated Linux system, just like the one that was running on our Zynq hardware. At this point now, we can start to experiment with other kinds of tools and drivers. So for example, I can actually ping my my router. Obviously the IP address of that router is unique to me. Let's see if the name server works. No name server. Mostly because I'm not routing. So I can ping my own machine, but I can't ping off my machine. And all that means is I can talk from this emulator out through my local area network, but I can't talk to a wider area network. We see here that it's emulating an ARM7 processor, but only at 166 megahertz. Compare that to the ARM processor that's on the ZedBoard at 666 megahertz. So, this is definitely an emulator rather than a full system.